Stanford, one of the world's greatest universities, is situated in Northern California, at the hub of Silicon Valley and at the gateways to the western United States and the Asia-Pacific region. Stanford has a world-class faculty, terrific weather, and a great Department of Petroleum Engineering.
Hi, I'm Lou Durlovsky.
And I'm Michael Garrison, and we're both professors in petroleum engineering.
Come meet the department.
Hi!
Ours is a relatively small department, which means that everyone is able to get to know their professors and their peers. We have 9 full-time faculty members, all of them highly regarded. All 4 of our senior professors have been elected to the National Academy of Engineering. We have about 60 graduate students, divided roughly evenly between MS and PhD candidates. Our students come from a wide range of energy-producing states and from countries across the world.
I'm from Australia.
Venezuela. There's lots of oil in Venezuela.
Well, we don't have much petroleum in Turkey, but we have a lot of petroleum engineers.
Nigeria.
Canada.
India.
South Dakota.
Tennessee.
Kazakhstan.
China.
New Zealand.
I'm from Taiwan. Thailand.
I'm from Idaho.
France.
Many of our students do not actually have an academic background in petroleum engineering, but most of them have a prior interest in the energy industry, for example through work, or family traditions, or national interests.
I'm actually a civil engineer, and I'm from the Philippines, and I worked with the Malampaya gas project.
I graduated as a mechanical engineer, and I've been working many years as a wireline logging engineer in the Middle East and China.
My background is in geology, and I joined petroleum engineering because of this integrated program in reservoir modeling.
My background is in environmental engineering at the University of Vermont, and I came to Stanford for the geothermal program.
I also studied civil environmental engineering, and I came here to work on CO2 sequestration and three-phase flow problems.
The class P246 is a great class because it gives geologists and engineers a chance to work with each other, and by doing so it allows geologists to see the scales at which engineers work at and gives engineers a first-hand idea of what heterogeneity is like in a reservoir.
I have to tell you, the courses here can be pretty challenging at times, but our professors are internationally recognized experts in their field, and the TAs, they and the TAs are very supportive. The assignments may be tough, but at the end of the quarter, the sense of accomplishment is real.
For the past 4 weeks, I think I've learned more than for the past 2 years I've been working.
Both MS and PhD degrees place a strong emphasis on research. Our research groups encompass a wide variety of energy-related topics, including enhanced oil recovery, reservoir simulation, reservoir monitoring, geostatistics, non-conventional well performance, geothermal and renewable energy sources, and environmental mitigation. Some students work on computational kinds of projects, while others work mostly in the lab.
We have a very cool thing here, invented actually here at Stanford, which is called the silicon micromodel. With these micromodels, we can perform experiments at true scale using the microscope, so we can observe at pore scale the multi-phase flow.
One of the most challenging problems in reservoir simulation is upscaling. My research topic is to develop upscaling methods which can capture the subgrid heterogeneity efficiently and accurately. In these slides, I show you the results. Here is the example which I show you using our newly developed upscaling method for this highly heterogeneous channel system.
I am a PhD student, and I am working on the optimization of non-conventional wells. And in this example, we are optimizing a multilateral well, a level 6 type of multilateral well, which maximizes the oil production.
So in the gas injection group, we're looking at trying to implement compositional streamline methods for predicting enhanced oil recovery methods. And in this particular study, we try to look at how streamline methods for compositional problems work compared to other solution strategies.
My PhD research is to develop an integrated method to evaluate reservoir fluidity, accounting for both geophysical and historical production data.
Hi, my PhD research is a stabilized finite element method for coupled geomechanics and reservoir flow simulations. And this is one example of pressure response based on stress change in the reservoir. With our newly developed stabilized method, and you can have a very smooth profile in the pressure response.
The department operates 2 X-ray CT scanners, which allows us to visualize and measure multi-phase flow inside of rocks. Graduate students in the geothermal energy group have been conducting experiments into boiling flow in fractured geothermal rocks. These studies have revealed fundamental differences between boiling and non-boiling two-phase flow. Not all of our research is related directly to oil and gas. Several students have undertaken studies into environmental issues like carbon sequestration, for example by investigating the formation of CO2 hydrates in the 2,000-meter deep water in nearby Monterey Bay.
The field trips are great. They were educational, but they were a lot of fun also.
The department enjoys a close relationship with industry, both in research and recruiting. In spite of rises and falls in the energy industry, Stanford graduates are consistently in high demand.
Fridays, we go out to the courtyard after a whole week of work, and then we just meet the other interesting people in the department. We share some drinks.
For more information on petroleum engineering at Stanford, visit our website at ecofisc.stanford.edu.